All right, now let's go on to our examples. Here's example number 1. It says find the mean and standard deviation of the variable friends in the Excel file. All right, so if you get the Excel file that you could download, go ahead and click on friends. We're going to be finding the standard deviation for the variable friends. All right. What would be nice is if we could do everything in Excel. But before we do that, I just want to make sure you understand how standard deviation works. And so because of that, I'm going to sort of have you do it manually first. So in order to do that, go ahead and go to Data, find the variable friends, click on that column, and I'm just going to copy that whole column and paste that right in here. So here I have my entire distribution of friends. And then I'm going to say, Excel, calculate the mean for us. And I'm going to use the function average and select all this nice data right here. Hit enter. And that's our mean, right? Now, that mean is not going to change for anybody, right? Because the mean is just the mean of the entire distribution, right? So I'm just going to put a pointer there. I'm going to say, hey, whatever the mean is on top of me, that's the mean, right? And then I'm just going to copy and paste that all the way down. And so this whole column should have the same mean, right? The reason I'm doing that is because that's going to make it easier for us to calculate squared deviation. We could just use the locked version of mean too. So there's different ways of doing it. All right, so now let's get our squared deviations, right? So deviation just means the distance from each value to the mean, x bar, right? Squared, right? And in order to do the square, we put in the caret and 2, right? And so we hit enter. And here's our squared deviation. Now I'm going to just drag that formula all the way down. And so we have here a whole bunch of squared deviations. Now, we have to sum up all those squared deviations, right? So here I'm just going to put in SS, because that's what we're going to get. And in order to get SS, we just add up this whole column. All right. And in order to get variance, right, or big S squared, right, what we need to do is take SS and divide it by N, right? So I'm going to take SS and divide it by my N. Now, I know here that my N is 100, but if you didn't know for some reason, you could use the function count and just ask it, count how many values there are. Not count if, but just count. Count how many values there are. Should be 100. And indeed, it's 100 because it just moved the decimal point 2 over, right? And so now we could get standard deviation, right, or S. And in order to get that, we just square root our variance. Excel has a function called square root, SQRT. I'm just going to square root my variance. And here I get a standard deviation of 428.64, blah, 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 right? Now, I made you do all that just so that you would understand how to calculate standard deviation. But Excel has a nice handy way for you to do it. So here I'm going to calculate S sort of automatically. Now here we're looking at just S, right? And in order to calculate S, we would do STDEVP because that's the one where you divide by N. Ta-da! Oh, standard deviation P. Oh, wait, sorry. I'm finding the standard deviation of all my squared values. That's wrong. I should be finding the standard deviation of my actual data, right? Yeah, so here, because in this method, you actually don't need any of this. I just made you go through it, just so you would learn. All right, but when we calculate S automatically using STDEVP, you see that we get the exact same standard deviation, and we don't have to do any of that mean calculating or calculating sum of squares or variance or anything like that. Now, there's even a way that Excel will calculate for you little s, the estimate of the population standard deviation from the sample. Now, that's the one that you'll be most likely using. And so because of that, I think that might be a good one for us to do. So sum of squares is going to be the same thing, right? I'm just going to actually copy all of this, right? So sum of squares is actually going to be the same thing. But variance is going to be a little bit different now. Instead of dividing by n, we're going to divide by n minus 1, right? And so I'm going to put in 99 instead of 100, right? And then square rooting, that works the same way. Square root of my variance, right? And so now notice that when we divide by n minus 1, my standard deviation is, oh, this should be lowercase s, also lowercase s. Notice that my standard deviation is slightly bigger than it would have been when we just divided it by n, right? And so now let's calculate little s automatically. And Excel always assumes that that's probably what you'll be wanting to do. So it made STDEV, just standard deviation. That default formula is going to divide by n minus 1. All right, so that we see that those two are the same values, sort of a shortcut, right? And so you see, when you automatically calculate it with Excel, you're not going to need to calculate mean or the sum of squares, but it's nice to know where those things come from. All right, so we did that already. Now let's find the mean and standard deviation of the tag photos in the Excel file. All right, so if you click over on data, let's go ahead and grab the tagged photos variables, values, that variable column, and then paste it right in here. It's just easier than going back and forth. And let's find the mean of this sample. So I typed in average, and I want it to average all of this, right? Then I'm just going to say, whatever's above me, that's the same mean. Copy and paste that all the way down. Everybody has the same mean. And then I'm going to get my squared deviation. So it's my value, my first value minus the mean squared, right? And then I'm going to copy and paste that all the way down. Great. Now let's get the sum of squares. And in order to do that, we just find the sum of all these squared deviations. And then in order to find variance, or big S squared, right? Actually, let's just do little s squared, because that's the one you'll be using for the most part, right? For little s squared, we take this sum of squares and we divide it by by n minus 1. We could use count. So count all of that minus 1, right? Right? And so, oh, I think I have an extra parenthesis in there. Right? So all of this is in my denominator, and I hit enter. So that's my variance. Now what is my standard deviation? My little s, my estimated standard deviation. Well, all I have to do is square root my variance, and that's what I get, right? And now let's check our answers by using the automatic Excel version. Here, we'll put an STDEV, stand dev, right? Oops, I almost did that again. I want to put in our actual data, our actual values. This is our real distribution that we're working with here. And ta-da! Excel does it nice and quickly for us. We don't need all of this stuff. In the future, we'll just be using this automatic version, but I do want you to know where that comes from. All right, let's go on to example 3. The average number of calories in a frozen yogurt is 250, with an estimated population standard deviation of 30. If 24 frozen yogurts from popular chains were sampled, what would be their SS, or sum of squares, right? Well, here, we know that we don't need the actual values and the means in order to find sum of squares, because we have some of the other pieces, and we could just sort of fill out what's missing. We could figure out what's missing. Well, we know that they have estimated population standard deviation, right? So that's little s, right? And in order to get little s, we know that they added up all of the x sub i's minus the mean, squared that, all divided by n minus 1, and then took the square root of that. We know that that's what they did. And another way of writing that is square root of SS over n minus 1. All right. So let's fill in what we have. They know that the standard deviation eventually is 30, right? So this S is 30, right? And what we're trying to find out is this. We don't have that, right? SS, we don't have that. But we do have n minus 1 because n is 24, right? So 24 minus 1 is 23. So from that, and only that information, we could figure out SS. And in fact, this mean, they've given us this mean, 250, is sort of a red herring. You don't actually need it in this problem. All right, so I'm going to use a little piece of my Excel as a calculator. And here I know I need to square 30. So 30 squared, right? And then I could just multiply 23 to that. So I get 20,700. So my SS is 20,700, right? And I didn't actually need all my values from the distribution, nor my mean. All right, last question. Example 4. This is a conceptual question. Hopefully your tests will test you on concepts. When you divide by n minus 1 rather than by n, what effect does this have on the resulting standard deviation? Well, n minus 1 is a smaller number than n, right? And dividing by a smaller number will result in a bigger answer. And so the resulting standard deviation, S, will be a little bit greater than this S. This one divides by n, and this one divides by n minus 1.